Assalamualaikum warahmatullahi ta'ala wabarakatuh, and good morning, my student class of production development. This is Dr. Rosmaini Tasmin again. We'll be lecturing on chapter 4 of your product development course, titling Product Specifications. In this lecture, it will be basically corresponding with your textbook, e-textbook, in which at chapter 5, product specification. So in this chapter, the presented product is very special. It is of a bicycle made by Specialized Bicycle Components Corporation, or S-Works. It is an American bicycle company. However, this is not a typical standard bicycle in which you will be using for cycling around your vicinity or cycling going to school. But this is very specialized bike, very rigid, very sturdy, and it costs quite expensive. And it is known as a mountain bike. Okay, this mountain bike basically is a very specialized bicycle, and it has very strong features. For example, like this front forks with suspension. Okay, and it is mostly used by users who has a strong interest in mountain biking. All right, and it is of normally of a high value because it will cost a lot. In Malaysia, maybe around 10,000 or 15,000 per bicycle of this nature. And it must be able to identify its customer needs, because its customer need is very specialized. Not all people wanting to buy this bicycle, because only certain enthusiasts, people who are about cycling, are needing this kind of bicycle. So in other words, for producing the specification of this product, so designer must interview the lead users and working closely with dealers, so that it can determine its final proposed cost and also its intended weight, final weight of the bicycle. So since this bicycle is quite special, let's take a look of a short video clip how this bicycle is actually being used by its actual users or its actual buyers. Okay, let's have a look on this short video clip how is this mountain bike is being used by its users. So this is very extreme use or extreme application of the mountain bike. Mostly it is for recreational and sporting purposes. Okay, I show you the halfway of the mountain bike, in which how does this mountain bike is actually being used by its user. It is so much so it could be dangerous. It could be in one another perspective. It could be interesting for its users, but in other perspective, it must be designed in such a way that the specification of this specialized bicycle must needs with its customer expectation and customer needs. That's why the title on product specification of this book is quite interesting to discuss. Okay, now you have understood what kind of nature of the product that you must design, because the customer needs is a very extreme, I would say very optimum, so as it will cost a lot, and customer are willing to buy if manufacturer could design such product that meets customer needs for its actual usage. Okay, so we must come up with the specification of such specialized mountain bike, right? So this is in the form of a specification, right? What does specification mean, right? A specification is actually a precise description of what the product has to do. What is the actual specific function that the product must execute? So that is specification. In other words, a specification is the language of customer. For example, this suspension forks, right? For mountain bike, one of the most rigid component that is enduring burden or enduring shock is actually the suspension. So the book chapter also discuss very specific on coming up the specification for the suspension, right? So if a customer want a very good mountain bike, what does it mean? Okay, for one thing, that designer could interpret that it must be able to reduce vibration to the hands, because when the mountain bike is descending from a very tall mountain or tall hill, so there are many shocks being absorbed by the bikers at his or her hands, right? So customer wants easy handling of difficult terrain. So how does it supposed to be maneuvering the difficult terrain of a mountain, of a hill? So as you have seen just now at the high speed on the bumpy trail, so it must be able to withstand the extreme shock towards the bike, and it must be able to handle rigid in cornering. In other words, the frame of the bike must be very sturdy. Okay, in overall design, the buyers want to, of course, feel pride of the bicycle that he or she owns, right? The other expectation by the buyers or the users of this mountain bike, it must be easy to maintain. For example, changing wheels, changing component is very easy to get done with, right? And it is expected that mountain bike must last a longer time. For example, it can last for 5 or 10 years. And last but not least, customer interpretation of the needs is this bike must be safe or must be able to be used upon crash, right? So these are all very difficult and stringent specification or expectation by customer. Yeah, it's all very extreme expectation, right? As such, it will cost quite expensive for this kind of mountain bike. Okay, upon doing your customer survey, right, on this mountain bike, say you are talking to or interviewing to potential customers or actual enthusiasts of this mountain bike, they say to you, right, this is their needs, right? All these are their customer needs of this mountain bike. For example, it must be able to reduce vibration to hands, right? It must be able to allow easy traversal of a slow and difficult terrain, right? So it must be a lightweight, right? It must be easy to install. So customer must feel pride owning this kind of mountain bike, right? It lasts a long time. It lasts a very long time. For example, 5 to 10 years, and it is pretty much safe if the customer experience crash landing with this bicycle. So all these are the needs of customer by the customer, and these are all belonging to the suspension. And this is the importance of the needs, right? 3 star, 5 star, 4 star. The list is easy. It's easy to install, right? So work with fenders, and it lasts a long time. Or it's very important. Safe in a crash is very important, right? The importance of 5. So these are the basic input prior deciding the product specification. So all these are the needs, and this is the importance, and all these are the 12 needs of customer expectation or customer needs during your interview or during your survey. Okay, now we have to come up with the technical product specification. Okay, so the technical or the actual product specification must be very specific, right? For example, the technical and product specification of this mountain bike, it must be such a way that it's got to be a tough bike, right? It must be a strong bike. It must be a sturdy bike. So key design variable of the product, such as the oil viscosity for the suspension, or it is spring loaded, right? For the suspension, so it must be determined, right? And technical and product specification must consist of metrics. So it is an actual measurement, or it could be a value, like 40 kilogram of force, and the average time to assemble maybe around 75 seconds, right? In order to assemble and disassemble the component, right? So it must be in the value, like for example, 75 seconds, just slightly more than 1 minute to assemble, right? And this technical and product specification must consisting of values. It could be a number. It could be a range from A to B, right? And it could be an equality. For example, the weight equal to 20. For example, the weight equal to, for example, 10 kilogram. For example, or the values of the technical or product specification, it could be an appropriate unit, right? For example, in second, or in kilogram, or if it is energy, in joule, right? So this technical specification or product specification must be very specific in order for us to design a very suitable product that meets customer expectation with its respective price and with its expected performance. Now, let's take a look on where we are in discussing this product development flow. So, in the previous chapter, we have discussed on the mission statement, identifying customer needs, and then here we are in establishing the target specification. Later, we generate the product concept, select the product until final specification, and later we develop the mass production of the product. So during all those process, we must perform economic analysis, we must do benchmarking, and of course, we must build the prototypes prior producing in a large amount. So this is why it is important to establish the specification, right? So this is the process flow in explaining, in transforming the customer needs into actual specification. Okay, the first step, we have to prepare a list of metrics, right? So list of metric is basically the measurement of the customer needs. Okay, for example, we have customer needs number 1 and number 3 that previously we discussed. What are the customer needs number 1 and number 3? For example, let's take a look. Okay, customer needs number 1, reduce vibration to hand. Customer needs number 3, enable high-speed descent on the bumpy trail. right? These are very specific customer needs from your interview. Now, you have to transfer these customer needs, right, into a matrix, evaluation of metric. For example, metric number 1, attenuation from dropout to handlebar at 10 hertz. For example, it means that the shocking vibration of the absorber must be able to absorb 10 shocks per second. Right? This is what they mean by 10 hertz. That it is like a 10 cycle per second, right? And this is to satisfy customer need number 1 and number 3. Number 1 says it must be able to absorb shocks to hand, and number 3, it must be able to handle maneuver during a bumpy trail, right? So the importance is number 3. It is 3 importance out of 5, and unit of measurement is in dB, which is in decibel. Okay, and the rest of customer needs are also being evaluated. For example, for matrix number 2, the shock absorber is using a preloaded spring design. It is using a spring, and this is to satisfy customer need number 2 and number 6, right? So what are the customer needs for number 2 and number 6? Let's have a look on our list of summary after your interview. Number 2 is it allows easy traversal of slow and difficult terrain. And number 6, it remains rigid during hard cornering. Okay, difficult terrain and hard cornering, right? So that is the matrix number 2, which is in order to handle hard cornering and difficult terrain, you need the shock absorber to be designed using a preloaded spring. That is the matrix, and the importance in 3 out of 5, and the measurement unit of measurement is Newton. So all these are the metrics which is listed in order to better design your mountain bike in order to comply or meet all the customer needs which are resulting from your interview. So, for example, the maximum tire width, right? Customer need number 9. So it is very important. It has very sufficient maximum width. It is measured in inches, for example, right? So these are the preparation of the metric list in order to satisfy all the customer need from customer need number 1, right, until number 20. Okay, now after a listing of the metrics, you need to have the I would say a metric that is joining the needs and the metric itself. So these are all the customer needs. You could see the metrics in X and Y, and customer needs from 1 to 20, from reduces vibration to hand up to it is safe in a crash. So now you plot it against the metric itself from 1, right, until number 26, right, which is this. Your needs is from 1 to 20, but your metrics of designing this S-Works bicycle is from 1 to 26. Okay, now you have plotted all the needs, 20 needs, respectively to the metrics, which is 26 metrics. All are plotted. It means that all customer needs are being taken care of, all those 26 matrices, from attenuation from the dropout to handlebar of 10 hertz up to bending strength frontal loading, which is metric number 26. So in this way, designer already ensure that all the customer expectation or customer need are met by creating respective metrics or measurement or actual value to be captured during the design. So now we have to we have to do, if you want to design a successful product, so we have to benchmark with the product which are already available in the market, which is a part of your competitor later in the actual market. So from this metric number, right, from metric number 1 to 26 and customer needs from 1 to 20. So these are the metric actual specification that you must meet. So you must compare your proposed new design mountain bike with the existing mountain bike in the market. For example, this brand, ST Tri-Track. Second brand, Maniray 2. The third brand, Rocktex Quadra. The fourth brand in the market is Rocktex Titanium 21. The fifth brand available in the market is Tonka Pro. And the sixth benchmarking mountain bike available in the market is Gunhill Head Shock. Okay. And out of all these six, so you must take their measurement so that you could quantify their actual value of their reading, right? For example, attenuation from dropout to handle a bar of 10 hertz, ST Tri-Track could handle 8 decibel. That is the lowest, and the highest in the market is Rocktex Titanium 21. It can handle 15 decibel, and Maniray could handle maximum 15 decibel of the attenuation from dropout to handlebar at 10 hertz. So minimum is 8, maximum is 15. So the rest of the metric also need to be observed from all the 6 brand of product which is available in the market. Okay, for example, wheel size. Okay, wheel size among all the brands are quite constant at 26 inches. So the wheel size or the tire size is basically radius time 2, which is 26 inches, right? It's 2 feet plus. Okay, so these are all available mountain bike in the market. They are all using the standard 26 inches wheel. So you could have used the same available standard wheel of about 26 inches. So all these values must be extracted out from the available brand in the market so that you can produce and come up with your own specification of that mountain bike that is currently you are designing. Okay, so that is step 2, benchmarking, in which you get the reading from the existing product in the market. Now, upon competitive benchmarking, so now you have to translate the value from the previous slide into a star rating. Okay, so if it is good, you give a star rating of 5. If it is in the middle, you give a star rating of 3. If it is minimum, you could give a star rating of 1, for example. So all these are translated from the value into a star rating. Okay, so that is in order to see which needs and have the best uh, parameter for having a good benchmarking. Okay, okay. For example, for this ST Tri-Track, they have 1, 2, 3, okay, 4, 5, 6, 7, 8. So they have quite as many as 8 5 stars. So then you could see some of the brands, how many of them got best features out of those 5 star, right? So you could see here, for example, Rocktex TI21, they have quite the most number of 5 star available in their specification. So those that with most 5 star number, you could benchmark it as the best. Those with the least number of star, you could benchmark it with the lowest spec. Okay, in the step 3, after benchmarking, you have to set the ideal and the acceptable values. Okay, of course, you cannot design towards the maximum, and that is available in the market. Normally, such bicycle is very expensive, and of course, you could not design with the least specification bike that is available in the market, which is the low spec. Perhaps you are designing in between the highest spec and also the lowest spec. You are designing in the middle. So ideal value is the best result of the team that could hope for. Perhaps we are approaching in the middle approach, right? Acceptable value is the value that would justify, barely make the product commercially viable into the market. Based on the concept generation and the concept selection, in which later will be discussed in the upcoming chapter, right? Okay, in this situation, you need to state in between the most upper spec and the lower spec. You are choosing in the middle approach. So you have to state your specification in the form of this 5 approach, right? Whether it is more than or equal to at least 325 kilonewton per meter as far as torque forces, or it should be less than equal to at most suspension force, which is less or equal to 1.5 kilogram, or it could be specification in between, like your value is basically lower than 800 newton and more than 480 newton. Okay, that could be in between value. Or you could set exactly like the tire wheel, right? The size of 38 millimeter, right? Or it could be set a discrete value, which is radius 1 cm or 1.125 cm. This is definite value. So you have to set the ideal and acceptable value so that you could design the product in between, the middle approach between the high spec and the lower spec. That would be a wise approach to pursue. On the step 4, we have to reflect on the result and the process. The team may require few loops or few cycles in order to come up with the best or the most comfortable design. As such, it is the goal to set not too high, and if it's fall back, you still at a higher range in the market. Okay, you could offer multiple products like product design A, design B, and design C. There must be no missing specs, spec which is derived from customer needs, right? And then you proceed to the most viable solution concept. Okay, say this is the setting of final specification. So you have the distance from wheel to wheel center. You have the length of the fork. You have the length of the head tube. Okay, you have this chain stay. What is the actual length? Right. So these are all basically the technical performance metrics need to be compared against the cost. Okay, in order to develop the prototype model or the technical model, right? Step 1, you need to have the tool for predicting the value of the metrics for a particular set of design decisions. Say you have designed the decision to be a middle approach, not too high and not too low. So you have to analytically and physically make approximation of the specification of the product, right? It could be oil dampened coil, spring concept, right? Or it could be a spring preloaded concept approach, right? All this could be achieved through design of experimentation or design of manufacturing. Okay. So in order to develop the technical product, so you need to assess the technical feasibility. For example, at attenuation of 10 Hz as the output, and estimated specific monster G reading, so you need a dynamic model of suspension performance analysis. It could be using a suspended mass, or it could be using the input or type approach of unsprung mass, or it could be using orifice diameter, or it could be spring constant or oil viscosity. All these must be able to dynamically simulate the suspension so that it can achieve this customer needs and its respective metrics. Okay, this is kind of a black box design. For example, to have lateral stiffness, right? So static model of the brake mounting stiffness, it must be analyzed, and it must have a good support geometry. It must have excellent material property, the tube geometry, and also the mounting points. So all these will produce a very good lateral stiff, right? And so on. So these are the design variables, the model inputs, right? From the 6 model that you have gathered, and you have surveyed, and you have measured the 6 model of the bikes from the market, and then you design a suitable approach to achieve it in order to satisfy the metrics or the model outputs. Okay, this could be your prototype of the technical model. This is what they call demonstration bike or demo bike, right? That could be your prototype. Okay, step 2 to develop the prototype model is to develop the its cost model. Okay, in this case, we are using the components of the basically bike, right? You have the steer tube, crown, boot, lower tube, uh, spring, orifice spring, oils, right? And decal sticker assembly cost at 20 US dollar per hour and so on. So for the quantity, like to produce this fork, right? So basically the higher margin is at $2.50. It is at a higher spec. For your lower spec is $2 per steer tube fork, right? Quantity of 1. So as such, your cost is $2.50 for the upper spec, and your cost for lower spec is $2 per fork. So you summarize all the costs to make this fork, right? So the fork of a high spec will cost the bike about 104.19 US dollar per high spec fork, and for the lower spec fork will cost around 78.68 cent US dollar for the low spec fork of the bicycle or the proposed bicycle. So as such, you have the upper limit, and this one you have the lower limit in order to come up with the first design of the prototype. And then you need to refine the specification, in which you have to repeat the process in order you get the best of the final specification of the product against your competitor, right? So in order to execute this, you have to do the competitive mapping, right? Or trade-off map, right? So this is to determine the high performance suspension of low monster score. In other words, is this a trade-off curve? So you plot in the x and y the graph like this, right? The y-axis is the estimated manufacturing cost for the fork, and this is the score in monster G scale, right? From at the x-axis from 3 to 4, and now you plot at a 3.2, for example, score on monster G, right? You could produce a fork which is around perhaps 67 US dollar per fork, right? So you plot the G value towards the estimated cost of manufacturing. So this is perhaps work for the concept B of your fork. And there is perhaps another optional concept for your fork, concept A. And from there, you also plot all the competitive benchmarking product that is available in the market, like 6 of them, 1, 2, 3, 4, 5, 6. So you plot their score G with respect to ST tri-track. So at it is achieving 3.6 monster G scale at the value of perhaps around 66 US dollar, right? Like for this, at for Gun Hill H shop, so you could achieve like the fork performance at 3.4 monster G at a cost of 100 US dollar per fork for its estimated manufacturing cost. So as such, you have the benchmark value on the upper uh, spec of a mountain bike, and this could be your ideal value, and this is the marginal value. From there, you could start producing the fork of your newly proposed mountain bike at perhaps at this range at as marginal value. Now, you have pretty much decided what is your final spec, okay? Because you have compared with the upper spec and the lower spec, and you decide on the middle approach. So, customer needs number one, attenuation from drop out to handlebar at 10 hertz, right? You need basically decibel. So, the value should be bigger than 12 uh, decibel. The spring preloaded, you could decide at the Newton unit between 600 to 650 Newton. All right. Maximum value for Monster G is basically less than 3.4. Right. So then, for example, the steer tube length, well, you have few options here, either 150 mm, 170 mm, 180 mm, and so on. Right. Unit manufacturing cost, perhaps it is kind of subjective unit, but it must have a value of more than 4 in terms of instead price. This is customer needs number 17, or this is metric number 17. Okay. And as far as metrics number 26, the bending strength or the frontal loading is more than 10 kilonewton. So this could be your final spec after benchmarking between the ideal values and the upper spec of the 5 brands mountain bike available in the market, and you could settle with the marginal values, for example, within this range, right? Okay, so that is your final spec summation of your newly proposed mountain bike for your newly designed product specification. Okay, so step 4 to produce the prototype of your mountain bike is basically to have the flow down spec, right? What is a flow down spec? Flow down spec is basically a product is made of many subsystems, right? For example, like this, if this is your bike, so you have fork, you have the rim, you have the bushes, you have the screws. So this is basically the your flow down spec in order to assemble a full mountain bike assembly, right? So basically, flow down from overall spec to subsystem, like this blown out diagram. All subsystem spec will produce ultimately overall system spec. So by this, you are meeting all the component needed in order to assemble a full spec of a newly proposed mountain bike. Okay, after producing all the final spec, remember you need to always do reflection of what you do some sort of rethinking on the design, rethinking on the manufacturing, rethinking on the assembly, so that you can come out with the winning product for your uh, mountain bike, right? So you need to isolate or take care of all the uncertainty in the technical model, and to produce the most viable cost. we need to choose a concept that is best for the market, perhaps the middle approach, right? So this is for the good of the technical model or future development of the subsequent products. So this will cover basically on the product specification chapter of designing a newly proposed mountain bike, which is a medium class between the upper spec and between the ideal spec. So I hope my lecture has been useful for you to understand this chapter on producing specification for the newly developed product. Okay, that would wrap up my presentation lecture for chapter 4, product specification of this product development course. Thank you for your attention and thank you for following my lecture. Till I see you again. We urgent here. Thank you, class.